So probably the easiest way to solve this problem is to realize that it's possible to prove that the area of a kite is half the product of its two diagonals. Okay, you can prove that based on the fact that the area of one triangle is 1/2 the base times the height. I won't go through the proof, but the idea is to use this formula right here. And to do that for this diagram, we need to find the length of the diagonals, given that this segment right here is 8 centimeters. Well, the diagonals of a kite bisect each other, so this is 8 centimeters over here too. And this is a 45-45 right triangle. And in a 45-45 right triangle, the legs are equal. So this is also 8 centimeters. So we need to find this segment length right here. You know what? I'll do that in red. And to do that, we're going to use the fact that this triangle over here is a 30, 60, 90, just because of this 30-degree angle right here. And in a 30, 60, 90 right triangle, the hypotenuse is twice the short leg. This is the short leg because it's opposite the 30. So if we needed to, we could say that this is 16. We don't really need that. But the long leg, which is this red segment, is radical 3 times the short leg. So this is 8 radical 3 right here. So the length of the long diagonal is 8 plus 8 radical 3. And the other diagonal is 16, 8 plus 8. And to find the area, we need to divide that product by 2. P times Q over 2. So this cancels. And if you want to, you can distribute that 8 and get 64 plus 64 radical 3. And if you needed to get a decimal approximation for that area, you could multiply 64 by about 1.732 or use a calculator. But that's the exact area right there, centimeters squared. Okay, hopefully that gives you some idea. If you have any questions, post a comment.